The mole concept, converting between mass and number of molecules. An aspirin tablet contains 325 milligrams of acetyl salicylic acid, C9H8O4. How many acetyl salicylic acid molecules does it contain? The first thing we're going to do is to sort the information into what is given, which provides us with a starting point, and what is it that we're trying to find. In this case, we're given 325 milligrams of acetyl salicylic acid, C9H8O4, which, to save space and time, I'm going to abbreviate with just the letter A. So we're going to say that we were given 325 milligrams of A, and what we're trying to find is the number of molecules of A. We need a way of getting from milligrams of A to number of molecules of A. And we're going to call this our conceptual plan. Which is also known as a flowchart. Now, this is much like planning a trip. You have a destination, that's what we're trying to find. We have a starting point, and that's what's given. And we need some landmarks along the way, some intermediate steps to help us. That's what we're calling our conceptual plan. Now, in a laboratory, we usually weigh things in grams. So in this problem, we're going to want to obtain grams of the acetyl salicylic acid, but we're given milligrams of acetyl salicylic acid. So we're going to need some sort of a relationship to allow us to go from milligrams to grams. We're going to call that relationship A. But a key link in solving problems like this is moles, because moles are related to what we can measure in a laboratory. That's grams. And it's also related to something we can't see in a laboratory, and that's molecules. So we're going to need two more relationships. we're going to need a relationship to allow us to go from grams of A to moles of A. We'll just designate that by B. And we need a relationship to allow us to go from moles of A to number of A molecules. We'll call that relationship C. So let's make a listing of our relationships. Okay, first of all, relationship A. Milligrams. A milligram of anything is equal to 10 to the minus 3 gram. What's relationship B? Relationship B is the molar mass. Of the acetyl salicylic acid, C9H8O4, which is calculated by summing the molar atomic masses that we get from the periodic table. We have 9 carbons, and so we're going to multiply the molar mass of carbon, 12.01. Now notice, by the way, that I've chosen 4 significant figures from the periodic table. That's because my data that was given to me contains 3 significant figures. And it's good practice to take one more significant figure than the data given to you. Okay, so this is the mass of our 9 carbon atoms. To this we're going to add 8 times the molar mass of hydrogen. That's 1.008. Again, that's due to the 8 hydrogens. And we'll add 4 times the molar mass of oxygen, which is 16.00. Okay, so that's 4 times the molar mass of oxygen from the periodic table. And this is 180.15 grams per mole. Now relationship C is Avogadro's number. That is, in 1 mole of anything, we have Avogadro's number, which is 6.02. And we'll take one more sig fig, 6.022 times 10 to the 23rd. In this case, that is the number of A molecules. Well, now we're ready to solve the problem. So we're going to start with our 325 milligrams of A. And we're going to apply a conversion factor that comes from relationship A. Now, since I'm trying to go from milligrams to grams, and I'm going to put milligrams of A in the denominator, and in my numerator we're going to put grams of A, and that relationship is that a milligram, the little letter M, stands for 10 to the minus 3 gram. So the milligrams of A cancel, and we now have grams of A. So we just completed the first step, and we're at grams of A. Second step involves going from grams of A to moles of A using relationship B. So B is the molar mass of A, and since we're trying to introduce moles, of A, and we're trying to get rid of grams of A, the grams must go in a denominator. So that's 180.15 grams of A are in 1 mole of A. So grams of A cancel grams of A, and we've now gone from grams of A to moles of A. The final step will take us from moles of A to number of A molecules, and we're going to employ the relationship designated by C, which is that 1 mole of A is 6.022 times 10 to the 23rd molecules of A. So 1 mole of A contains 6.022 times 10 to the 23rd A molecules. So the moles of A cancel out, leaving us with molecules of A, which is what we're looking for. So this should give us the right answer, which is 1.09 times 10 to the 21 A molecules. Now that's what our calculator gives us, but it's always wise to check our answer. In other words, let's see if this answer makes sense. Remember that 1 mole of A has a mass of approximately 180. That is 180.15 gram. And that contains 6.022 times 10 to the 23rd molecules of A. But we don't have that number of grams. We have 325 milligrams, which is 0.3 325 grams. Since this number is less, in fact significantly less than 180, we should have a smaller number than 6.022 times 10 to the 23rd molecules. In fact, we have 1.09 times 10 to the 21st molecules. And so our answer makes sense.